And the next thing we'll look at is the routing. Okay, so let's look at that. The V6 routing. Before we even do that, we'll look at how we're going to configure V6 on Cisco routers. So, to enable V6, we need to do this. IPv6 is not on by default in Cisco iOS, so you need to switch it on. I hope one of these years it will be on by default. I mean, if you have Cisco, the CRS or the GSRs running iOS XR, that will have V6 on by default. But if you're using iOS routers, it's not on by default. So to switch it on, we need to do IPv6 unicast routing, that switches it on. We need to switch on Ceph. So Ceph is Cisco's way of doing forwarding table, routing table, and so forth. If we don't switch this on, then the router just builds a cache, a lookup cache. And it takes CPU and so forth. It's not very good. Right, so we have IPsec. We need to switch this on, so we'll see that in the lab. And we need to disable source routing as well. So no IPv6 source routing. So when we do the lab, we'll switch those three things on. To configure V6, we go to the interface and we just do IPv6 address/prefix. And so similar to V4, only we have IPv6 address. And we can put in the slash notation, unlike in V4 where you've got to write 255.255. and so on. If you want to use EUI64, you can, but I don't recommend it. An EUI64 address means we take the MAC address and append it to the first 64 bits. So it ends up being very big, lots to type. I mean, I'll show you an example. It really doesn't look good. Doesn't scale, very hard to manage. If you don't need a global V6 address, right, you're only going to use a link local address, then to enable V6 on the interface, you just do IPv6 enable. That switches on V6 in the interface, creates a link local address, and you can use that for communication between the two devices. If you configure a V6 address on an interface, it automatically creates a link local address as well. So we look at the examples. Here we go, IPv6 unicast routing, IPv6 Ceph, in fast00, go to the fast Ethernet, V6 enable, and here we are. V6 is enabled. We've got the link local address. We've got the MAC address here, A8B9C0FFFE00F11D. So that's the link local address. And the router says no global unicast address is configured. And we've got solicited no multicast here, MTU and various other things. Right, so that's how we switch on V6, but with just a link local address. So you get this router interface can communicate with other routers on that LAN using link local addresses. For EUI64, so there we've configured the interface as EUI64. So again, V6 enabled. We've got the link local address. Here's the global unicast. You see why it looks horrible? You've got 201 DB8, and then you've got that 64 bits EUI64. And if you're typing in neighbor addresses and so forth in the router, can you imagine typing all this in? You really, honestly, you don't want to. Right? The chances of making a mistake there is high. What if you change the Ethernet interface? The MAC address changes. So then you have dependencies in the network because the V6 address has changed. The V4 address won't, but the V6 will do because the MAC address is different. Anyway, so that's what that looks like with EUI64. And with static addressing, it looks like this. See, you can keep the address nice and simple. 201 DB8:2. Much shorter than the EUI64 version. Okay? So that's the static addressing, and that's what we do on routers. So routers and servers we have static v6 configuration. We don't use auto configuration. It doesn't make any sense. So now we go to the routing protocols. Well, static routing, easy. It's the same as IPv4. Only now we say IPv6 route. Destination, the gateway, and any protocol distance we want to set. The default for static, of course, is 1. I just made it 150 as an example. So that's a static route in v6. It looks like the same thing in v4. The nice thing is we can do the slash notation here, prefix notation, rather than writing out 255 to 255 and so on, as we did in v4. So that's easy. What about the default route? So line 1 is on this address block, line 2 is on that one. So router 1, here's the configuration, pointing to router 2 as the default gateway. Just do IPv6 route. Here's the default, /0, 21 deviate 21 :E. So the default route works the same way as it does in v4. No 0.0.0.0, it's now :/0. So default is quite easy. Dynamic routing protocols in v6, these are no different from v4. We still have IGP and EGP. We still use longest match lookup. We still have RIP. We still have EIGRP. We still have OSPF. We still have ISIS. But these 4 protocols have been extended to support v6 prefixes as well. So we have RIP-NG, which carries IPv6. EIGRP has now been extended to carry IPv6. OSPF version 3 is for IPv6. And ISIS has been extended to carry IPv6 as well. So the only one that's slightly different is OSPF v3. OSPF version 3 is only for IPv6. OSPF version 2 is still for IPv4. This is one of the reasons why we're using ISIS in the workshop. Because if we were using OSPF, we'd have to use OSPF v2 for IPv4 and OSPF v3 for IPv6. And this becomes very painful to manage. But I do some workshops using OSPF instead, and we always take much longer to get the workshop running than compared with ISIS. I mean, in fact, the next workshop I'll do in the Pacific will be using OSPF rather than ISIS. And it will take, I know it will take me longer to get the lab up and running. Right, so those are the 4 protocols. Nobody uses RIP. RIP's useless. So choice really is OSPF v3 or ISIS. ISIS for v6 is very, very easy, as you'll see when we do the lab. As for BGP, well, BGP has been extended to carry IPv6. So that's very simple. Configuring the routing protocols. Well, with IPv4, we kind of glossed over this. I mentioned yesterday, BGP has this router ID. And also pointed out OSPF router ID. It matters more when we come to do v6, because the router ID for a v6 protocol is still a 32-bit integer. It's still a 32-bit integer. Now the router ID is generated from the loop MAC address on the router. So if the router's got v4, this is fine, because we can just get the router ID. And because we're deploying dual stack, this is not a problem. But for anybody who wants to deploy v6 only, you need to manually do the router ID. So we need to do router ID and put in a 32-bit integer. So bear in mind, if any of you want to do a v6 only network, you need to manually configure the router ID. That's very important. But for us, we're going to run the network dual stack here, so we don't have to worry about it. RIP-NG, don't go here. EIGRP, well, I'm not going to go through it really. EIGRP is multi-protocol anyway. I mean, it carries IP, IPX, AppleTalk, and so forth. So adding IPv6 was very easy. It's just another address family. Right, so I won't really bother with it. OSPF version 3, well, OSPF v3 is OSPF for IPv6, based on OSPF v2, but it's only for v6 prefixes. That's the major important difference. It's only for v6 prefixes. It runs directly over IPv6 as well. It has no interaction with OSPF v2. So if you run OSPF v3 in one router, OSPF v2 in another one, they won't talk. OSPF v2 is only for IPv4. OSPF v3 is only for IPv6. So it's a bit confusing because people think, well, OSPF version 1 was for classful routing. OSPF version 2 was for classless. But OSPF version 3 is for IPv6. So it doesn't really make much sense. So people find it a bit confusing. So we need to run OSPF version 3 and OSPF version 2 in a dual stack network. So it's a very good reason why not to run OSPF. Main differences: OSPF v3 runs on a link, not a subnet. But this feature is being backfitted by most vendors to OSPF as well. So you can run OSPF v2 on a link also. So that's handy. Topology is not v6 specific, fair enough. Standard authentication mechanism, so OSPF v2 has its own built-in authentication. OSPF v3 uses IPsec. OSPF v2 used standard global IPv4 address. OSPF v3 uses a link local address. So all the next hops in OSPF v3 are link local. Flooding, slightly different. 2 new LSAs, also. So the configuration example could look something like this. This is from v6 only network. 2 interfaces on router 1. IPv6 router OSPF. We have to set the router ID because we're only running v6. Then we go to the interface. Remember, we run v6 on the link. IPv6 OSPF 1 area 1, IPv6 OSPF 1 area 0. See how it's different? Whereas OSPF v2, we had network statements for everything. It was always network statements. OSPF v3, we have no network statements when we have running OSPF on the actual link instead. Okay. That's all I'm going to say about OSPF v3. I mean, if you're using OSPF in your network today, hopefully after this workshop you'll think about it, move over to ISIS and use ISIS instead. Okay. You'll find that it's actually much easier to run. I hope. I think it's easier to run. Now, ISIS history. Well, yesterday I talked about ISIS being developed by the ISO folks for CLNS traffic. We've got the type length values and so forth. RFC 1195 added IP support. ISIS runs on the link layer. RFC 5308 adds v6 address family support. RFC 5120 adds MultiTopology, which I'll talk about later. So we've got 2 TLVs, we've got reachability, the interface address, I won't really bother with them. But we look at the configuration. So ISIS, we've seen router ISIS, we've got the NSAP address here. We just have a v6 address family for any v6 specific content. We've already seen IP router ISIS and interface. To enable v6, we just do IPv6 router ISIS on the interface. And that puts the interface running both v4 and v6. MultiTopology, I'll jump over this because I've got an ISIS presentation coming up which explains it better. Right, for BGP, so BGP was also extended to carry v6 prefixes. So BGP historically was just for IPv4. And then we had to carry multicast prefixes in BGP as well. And then, well, after multicast, we had to carry V6 prefixes. So BGP was extended to be multi-protocol, supporting multiple protocols. And so here's the V6 specific. We've got an address family information. So address family 2 is IPv6, and it can be used for, well, unicast, multicast, and all the rest. So looking at BGP configuration, so again we've got address configuration, router BGP, we have the neighbor specifying the address here, remote AS, and now we've got address family configuration appearing. Right, so V4 at the moment you don't have any address family, but as soon as we go to add in V6, we now see the configuration split into V4 address family, V6 address family, and so forth. So again, I've got slides. The BGP presentation shows this in a bit more detail. Okay. So, ISIS. So the ISIs for V6. So I've got a bit more detail than I had in the earlier setup. Right, so we'll look at ISIS standardization, ISIS for V6 and the multi-topology. So as I said, this was the history. ISO 10589, RFC 1195, 5308 added V6 address family, 5120 added multi-topology. The advantage with multi-topology, it means that you can run V4 and V6 topologies that look different. Very useful for rolling out V6. And so we're going to use multi-topology in the lab, and hopefully it will all work. Right, so we've got the two TLVs I mentioned, V6 reachability, V6 interface address, doesn't really matter. And we've got a new network layer protocol identifier as well, which lets ISIS routers with V6 support advertise V6 payloads. So that's really been the only change, a minor change to the protocol. So looking at the V6 piece, right, we've got a single SPF running for OSI, V4, and V6. Because this is single topology, you're not going to have different things for different protocols, which is fine because it means that all routers in an area must run the same set of protocols. It can be V4 only, V6 only, or V4, V6. And we're going to run V4, V6, dual stack. Simple rules. If ISIS is used for both V4 and V6 in an area, both protocols must support the same topology in that area. You can get it to ignore the topology or ignore the different types, but this is a really bad idea. There is that no adjacency check command you may find, but we want to make sure if you have an interface talking V4 and V6, that all other devices connected to that interface also are talking V4, V6. All interfaces configured with ISIS V6 must support V6. In fact, you can't configure ISIS V6 without a V6 address being there. What else is interesting? All interfaces configured with ISIS for both protocols must support both of them. Seems fairly obvious. V6 configured tunnel won't work. You need to use GRE if you want to run V6 over a tunnel. There are various restrictions. Right, if you've got scattered V6 support, not a good idea. You can't really do this. That's where the multi-topology ISIS comes in. It will only form adjacencies with similar configured routers, so you've got V4 on one side and V4, V6 on the other side, they won't talk to each other. That's a common issue if you're trying to deploy V6 incrementally. Because you've got V4 one side, V4 another, you add one router to bring in V6, you'll find that the ISIS adjacency will stop working because the two sides of the link are supporting different protocols. One is V4, V6, the other one is just V4. So if you're deploying V6 in ISIS network, you have to activate them both ends of a link at the same time, which is problematic. So that's all I need to say here. So you can do something like this. Right, so all the blue routers are running dual stack. The orange ones over here are just running, what did I say, running v4 only. So yes, this one will talk v4 only. We can make this interface v4 only, and there's no issue. But you can't have orange routers scattered in the middle of the network here. Things will break pretty badly. The CLI is familiar. But all we need is a v6 address family mode to enable features specific to IPv6. So here we go, router ISIS, whatever, NSAP address. I've done a redistribute static as an example. Address family IPv6, redistribute static. So we'll see in the lab there are some options specific for v6 within the ISIS configuration. Specific attributes, well, we've got the address family. There's the adjacency check I told you about. Don't use this. You can change the protocol distance for ISIS as well if you want to. There's no real need to do that ever. Maximum paths, if you want to do load balancing over parallel links, you can use that. We won't do it in the network. Default information originate, if you want to introduce a default route into the network. That's the command there, similar to OSPF. If you want to do aggregation, the summary prefix command does that. You can do redistribution, of course. Try to avoid doing this if you at all can. What else? You've got leaving the address family command. You've got the show commands, show IPv6 protocols. I'll show you the examples of that. So we get to a configuration example looking something like this. Right, you have the LAN here. We're sitting on router 1. It's on this area. We've got the LAN connecting to somewhere else. Router ISIS, we've got the NSAP address. Address family v6, we're doing a redistribute static. And then on the interface, we just do IPv6 router IS circuit type level 2 only. Just an example, showing the syntax. Dual stack is more common. So router 1 again is dual stack, Ethernet 1, Ethernet 2 between these two LANs. ISIS, so we've got the v4 redistribute static, v6 redistribute static, Ethernet 1, IP router ISIS, IPv6 router ISIS. Ethernet 2, again, IP router ISIS, IPv6 router ISIS. So you see how that all works. We'll do this in the lab this afternoon. You'll see exactly how we do all this. I'll show you all the show commands and everything. ISIS display, this is taken straight from router 1. So router 1, when you do the lab this afternoon, this is what you will see. So we do show IPv6 route ISIS. It shows the ISIS entries in the routing table. Right, so I2, here's the destination. So this is router 2 loopback. Next hop address. Notice the next hop addresses. They're all linked local. In v4, the next hop address was a v4 global address. In v6, it's a link local address. So this takes a little bit more troubleshooting when you're doing any troubleshooting, because your link local addresses are the next hops. Actually, I find it a bit frustrating because you don't know what device it is. The only way to find out is actually to connect to this address, well, connect to that link local address. So it is a bit frustrating. We look at the ISIS v6 RIB, show ISIS IPv6 RIB, same as you did for the v4 one. Right, so here we have all the entries. So it's a detailed RIB, the LSPs, and all the rest, the metrics and so forth. Show CNS IS neighbors details, so we can find the details about all the different neighbors. So here's router 1, router 4, router 14, taken straight from the lab. Says what it can do, so it's got the area, it's got the IPv4 address, it's got the v6 address, how long it's been running, non-stop forwarding. The type, the priority, circuit IDs, and all these types of things as well. So that's a typical display. Now, multi-topology ISIS. This is used by ISPs who are deploying v6 on existing IPv4 infrastructure. Running single topology ISIs means that enabling ISIs on a V6 point-to-point link must be done simultaneously at both ends. Right? You have to do it same time at both ends. Otherwise, you get a mismatch. If you've got V4 on one end and V4 and V6 on the other, they won't talk. Because when they try and bring up the link, they say, well, hang about, you're talking V4, V6, I'm only V4. That's a mismatch, we can't do this. So you'll find the adjacency will go down. So ISPs who are running existing V4 network, who want to deploy V6, generally will enable multi-topology ISIs across their network, and then they will go and deploy V6, because that way they don't get adjacency going down, and that leads to breakages in the network. Right? So multi-topology is actually very important. Adding new routers on broadcast media in a single topology ISIs is actually very tricky. I mean, as one of my co-instructors who teaches at Apricot and AFNO, he was running a big ISP in Malaysia, and they had big problems with, they have Cisco and Juniper routers on the network, they had big problems trying to deploy new devices in a single topology setup. And the reason is, when they plug in the Juniper router, Juniper will bring up V4, V6 at the same time. Whereas Cisco will only bring up V4. So you add a Cisco router into a V4, V6 LAN, it'll bring the whole LAN down. So you actually have to switch on the router, bring up both V4 and V6, then plug the cable in. That's not a very good situation. So multi-topology was the way of fixing this, and that way you didn't get breaks when you were introducing new routers. So as I said, we will use multi-topology here in the lab. Right, so ISIs for V6 assumes the V6 topology is the same as for the V4, single SPF, so single shortest path first, multiple address families. Most networks are like this, but some aren't. So multi-topology solves the problem. We now have two topologies. We've got the ISO V4 one, and we have a V6 one. So we now have two SPFs running. One for V4, the other for V6. And this is much better. So there are restrictions. It's not compatible with previous single SPF model. So that's why, again, we've got to be careful. You can't run single topology some places, multi-topology the other. Right? If you run multi-topology, everything must be multi-topology. What else? It could be V4 or V6 or V4, V6 configured on the interfaces. So what you generally do when you want to deploy V6 is you first go around all the routers, make them multi-topology, and then you start introducing IPv6. What else? The only other point here, wide metrics are needed, but ISPs should be using wide metrics anyway for ISIs. So multi-topology then becomes easier. So you can have a V4 only router sitting here. So V6 best path might be around that way, whereas V4 might be this way. Right? So we now have different topologies for V4 and V6. So it gives us more flexibility. So if you have routers in your network that cannot do V6, you can still run ISIs without breaking things. So the configuration example, it adds one line. Multi-topology. So address family V6, multi-topology. One line is added into the configuration, and we now have a multi-topology setup. Notice metric style wide also required there. Otherwise, it looks exactly the same as the V4 setup. Sorry, the single topology setup that we talked about before. Transitioning from narrow to wide metrics, I mentioned this yesterday, not really interesting for us. Multi-topology displays, you can do show CLNS neighbors. Right, you've got router ID, Ethernet, you've got SNPA, and then you've got the protocol. Rather than running ISIs, it's now MISIs. What else is on here? Show ISIs database detail. Topology, a V4 topology has got this identifier, V6 topology has got that identifier. Right? We've got separate topologies. And then there's various other things sitting in there as well. For support, Cisco iOS 12 to SRE. So if you've got 7200 or 7600 routers, it'll work fine on SRE. You shouldn't be using anything older than this anyway. SRE has got most of the latest fixes in it. SRD and older is really bad stuff. If you're using a 6500 switch, SXH or SXI have multi-topology. 12.14, so if you're using regular routers like 3800s and so forth, they all support multi-topology. 15.0 onwards all have multi-topology. We're using 15.1 for the workshop. So this all has multi-topology. If you're using 12.3 and 12.4, you can configure multi-topology, but the commands don't work. You can actually configure it there on the router, does nothing. In fact, it breaks your network. So you don't want to use multi-topology for 12.3 and 12.4. I used to do this workshop with 12.4, and I couldn't use multi-topology because it just didn't work. For iOS XE, so if you're using the ASRs, 3.3 onwards, iOS XR, 3.9 onwards. For Junipers, no issue. Most of the 9 point whatever releases onwards, multi-topology is no problem at all. So I thought I'd just put this in just to let you know what is and isn't supported. So that's IS. So even though I've been a lot of talking, it's actually quite simple. So the last one I'll do is BGP. This is a short set of slides as well. And then we'll have lunch. Right, so the BGP enhancements. RFC 4760, I think I mentioned that already, extends BGP for multi-protocol. So lets us do MPLS, so carrying VPN tunnels. Lets us do IPv6, lets us do multicast. RFC 2545 are the specific V6. So those are multi-protocol extensions. 4760 are the actual V6. No, wrong way around. 4760 is multi-protocol extension. 2545 defines IPv6. Right, so this is just whole definition of address families. Won't worry about that. This one's more interesting. 2545 defines the V6 specific. This number is very low. It's a low RFC number. So V6 supported BGP has been around for many, many years. Since about 1997. So we've got all the different address family definitions, of course. The first thing that changes is the next hop. When the two BGP speakers are in the same subnet, the next hop address is both a link local address and a global address. So that's one change. If the peers are not on the same subnet, then the next hop is just the global address. So that's one thing that's different. The next hop address for BGP and V6 can also include link local. Routing information, we've got one RIB per protocol, so V6 has its own BGP table. Best path selection was done for the BGP, so they're separate topologies, if you like, using ISP. So V4 BGP has its own BGP table. V6 BGP has its own BGP table. Best path selection is done independently. You can apply your own policies per protocol. You can share the peering sessions if you want to. I don't recommend it because it makes it more complicated. The next attribute, right, so router A and B peer with each other. Next hop is global and link local address. But router B peering with router C, typically for IBGP, the next hop is just a global. We can't have link local because link local only applies here. So that's one difference. BGP runs on top of TCP, so you can run the BGP peering on V4 or V6. So we can run a V6 prefix updates over V4, or we can run V4 prefix updates over V6, or we can run V6 prefixes over V6, whatever. There are many combinations. I've talked about the router ID before. If we're running a V6 only network, we need to set a router ID, otherwise nothing works. for configuring the peering, we can use FE80, link local addresses, for eBGP. It's not recommended because the link local address is only used on the local link. It's not visible outside. So even if you use link local, you still have to reset the next hop address. It just makes it more complicated. Use global addresses as we do with v4. Now on iOS, it's slightly strange. It assumes that all BGP neighbors are v4 neighbors. It doesn't matter how they're configured, it assumes they're all v4 neighbors. So an important thing you need to do in iOS is no BGP default IPv4 unicast. We need to remove this assumption that the neighbor is a v4 neighbor. If you don't do this, then the configuration looks really strange. I mean, some of you might forget, and then you'll see what happens. So doing the regular peering, right, router BGP1, no BGP default IPv4 unicast, neighbor, v6 address, remote AS. Here's the address family. We activate this neighbor in the v6 address family. So the address family means we're going to send v6 prefixes on this neighbor. And we're going to send these to networks on this v6 neighbor. You can do link local peering if you want. Right? You can specify the link local address. Look, it's a very, very big address. Easy to make mistakes. But then we need a route map which fixes the next hop. We can't use a link local address as the next hop address in BGP. It's got to be a global address. Right? So we end up setting a v6 peering between link local. We then have to rewrite the next hop to a global address. So why do this complicated thing when we could just do it like this with no route maps? So that's why I say, don't do this. So for v4 and v6 peering, dual stack, typical dual stack setup, no BGP default v4 unicast, v6 neighbor, v4 neighbor. We set up the v4 neighbor here in the v4 address family, v6 neighbor there in the v6 address family. Quite simple. The filters, v4 filter looks like this, IP prefix list, v6 filter, IPv6 prefix list. We'll talk about filters more tomorrow. How to sort out the configuration. My advice is to put all the v6 configuration into the v6 address family, all the v4 configuration into the v4 address family. And the router will sort this out. It knows what has to go where. It knows what's generic and what isn't. So you would type it in something like this. Right? No router BGP 10, default v4 unicast, v4 address family, remote AS, filters, network, done. That's a generic v4. Put in the v6 configuration here, v4 there, v6 here, generic in black, specific in red. But when you do a show configuration, the router prints this. Right? It puts the generic configuration up there, and then all the specific configuration in here. So when we're doing the exercises for the rest of the week, if it's v4 exercise, go into router BGP address family IPv4. If it's v6 exercise, router BGP address family IPv6. Okay. If we're doing all the attributes, we'll see this when we get to doing multi-homing. It's the same things. Right? So we'll see this later in the week when we do this ourselves. Nothing is different. You can carry v4 prefixes inside of v6 peering. So you do neighbor, v6 address, address family v4 says, I'm going to carry v4 prefixes in this peering. You can do it if you want. The only problem is you've then got to fix the next hop. The next hop address for a v4 destination must be a v4 address. The next hop for a v6 destination must be a v6 address. So even though we can carry the prefixes, we need to change the next hop like that. So again, this is unnecessarily complicated. It's better to run a v4 peering for v4 prefixes, v6 peering for v6 prefixes. The show commands, usual things. It's changed though. It's now show BGP IPv6 unicast. And we've also got show BGP IPv4 unicast. For v4 we had show IPBGP, but now it's show BGP IPv6 unicast. So a slightly different show command. And the summary just looks normal. Right? We've got the same show BGP IPv6 unicast summary. We've got the router ID and so forth. Here's a neighbor. Same type of display as we saw with the v4 peering. And that's it. BGP is extended to support multiple protocols. v6 is just one more address family. If you have experience with v4 BGP, v6 should be very, very simple for you to move over to using. Okay? So that's all the v6 presentation I've got to do, apart from the case study, and we'll probably look at some of the transition scenarios as well. But that's all we need to do the labs. So when we come back after lunch, I'll explain how the lab works. And we're going to take the existing lab that we have, we're going to add ISIs to it for v6, and then we're going to add BGP to it for v6.